Hello, my little mathematicians. Today we're going to go through geometry handout number 8 of volume of rectangular prisms. Okay, so let's go ahead and take a look at what it has to say. First off, volume is the amount of space that's inside of a 3D object. Okay, so it's the space inside versus surface area is like if you wanted to wrap the present, you find the area of every surface. So that's how the volume and surface area differ. Okay. Just like area is measured in square units, okay, volume is measured in cubic units. Okay, so it's measured in cubes. So a figure is packed with unit cubes, like this one. Okay, even if not all the cubes are visible or showing in the picture, they're still there, right? Okay, and they're still a part of the volume. So could you label the length, width, and height of each figure and then describe how the dimensions and the total number of cubes are related? Okay, so let's go ahead and take a look at this guy. The height right here is what? We'll count 1, 2, 3, 4. And then the width right here, how many are there? Yeah, 2. And then this is the length, that's 1, 2, 3, 4, 5. Now, if you accidentally switch like, oh, I thought this was the length and that's the width, it doesn't really matter because 2 times 5 is the same as 5 times 2, right? Okay. So now what's the total number of cubes? Well, what you're going to do is you're going to multiply the length, width, and height, right? Like if you were to count all those inside. Okay, so that is 40. Okay, here, how tall is this height? It's 3. And then the width right here, 1, 2, 3. And then the length is also 3. So if you were to count like here and then going back and up, basically that's just multiplying it, right? So how many total cubes then are inside? There's 27. Okay. And then here it's 1, 2 high. And then the width is only 1. And the length right here is 3. So 2 times 1 times 3 is 6. Okay, or again, like you could have actually counted them, but to me it's really hard because you can't actually see all of them in there. So that's why I do the multiplying the length times width times height. Now where that actually comes from is because in the future you're going to be having different types of shapes. And so volume is always found by whatever the area of the base is times the height. So if you do the area of this base shape and then multiply it by how high it is, that's going to fill up the whole figure. But for these particular lessons, we're only going to be dealing with rectangular prisms. And the area of a rectangle is length times width. So that's where that comes from. And then again, times the height. So that big B stands for the area of the base, not just the base length when we think of like base times height, but it's the area of the base. And that area of the base is a rectangle, so length times width. So these are essentially saying the same thing. Okay, moving on. Volume can be determined by finding the area. Okay, again, that's that big B, okay, of the base shape, and then multiplying it by the total height of the object. That's what separates one base from the other parallel base. Okay, so we're going to use that formula in order to solve these different problems. Okay, so the formula is area of the base times the height. Well, this base right here is 9 times 6, right? And then that height that separates the two bases, this base and this base down here, is 4. So go ahead and multiply all those. 9 times 6 times 4. And what do you get? Yeah, you get 216 cubic centimeters. Or you also could have done, hey, I know the area of the base is the length times width and then times the height. So length times width times height, that's 9 times 6 times 4. Notice how it's exactly the same thing. Okay, so that's why those formulas are interchangeable with each other. Okay, let's go ahead and try those here. Okay, if sometimes they like to do the area of the base times the height. So let's do that for these because all these problems are asking you, hey, can you find the volume of these rectangular prisms? So let's do the area of the base shape separate from the height and have it stand out just because some of them are insistent upon that. So what two numbers would you multiply for the area of the base here? Yeah, the 8 times the 4. And then which one's the height? That would be the 6. And then go ahead and multiply that out. Well, the area of the base, that part's 32, and the height is 6. So then your total volume is, what'd you get when you multiplied that in your calculator? 192 cubic centimeters. So can you go ahead and do that for these problems? Can you find the area of the base first and then multiply it by the height? Okay, don't forget, write the formula each time so that it gets stuck in your head, and then actually plug in the numbers. I know you can use a calculator, but show what you did. So if you paused it and unpaused it, when you come back, okay, you should have done 8 times 8 for your base, and then 1 times your height. Well, the area of the base, 8 times 8 is 64, and 64 times 1 is just 64. So this was 64, and you're like, wait, how did you get centimeters for this one? It's because it said up at the top, all measurements are in centimeters. So these are all centimeters. And it's cubic centimeters because you did length times width times height. So 8 centimeters times 8 centimeters times 1 centimeter, and centimeters times centimeters times centimeters equal centimeters cubed. That's why volume is always in cubic units. Okay, so for this one, what was your length and width for the base? Yeah, 3 by 18. And if you switched 18 times 3, who cares? Okay, and the height of the whole figure is 22. So when you multiplied 3 times 18, what'd you get? And then go ahead and multiply that answer times 22. And what'd you get overall? Yep, 1,188 centimeters cubed. Okay, last one we're going to do with this formula. Okay, which one's the area of the base? Yeah, the 9 times 25. And then which one's the height? The 10. So go ahead and multiply 9 times 25. What'd you get? 225. Now multiply that by 10. Okay, so your final answer was 2,250 cubic centimeters. I just wanted you to be familiar with using that formula in case sometimes like they actually give you the area of the base, then you would have that part done and then you just multiply it by the height, okay? But most of the time what we're going to be doing with these rectangular prisms is length times width times height. So go ahead and write that formula for each of our remaining problems, okay? Because again, you always want to have the formula written out. And then plug in what you know and solve. Okay, so pause the video, do these, unpause it, and come back. Okay, you're back with us. Let's see how you did. Well, this one, they didn't actually tell me the measurements, but I can count the number of boxes, right? Here along the length, that's 1, 2, 3, 4, 5. This width is 2, and the height is 1, 2, 3, 4. If you got that, that was half the battle. Now, this seems easier said than done, but you'd be amazed at how many kids can't plug it into their calculator correctly. So what'd you get? Hopefully you got 40. I mean, this one you could have even done in your head, right? 5 times 2 is 10. 10 times 4 is 40. Here, length is 12. You should have put the width as 6. If you switch both of those, who cares? Length times width is the same as width times length. And then your height that separates the two, that's the 3. Just because later in the future, you're going to want to do area of the base times the height sometimes. The only one that I really care about is that you can identify which one's the height. Okay, plug that into your calculator. What'd you get? Hopefully you got 216 cubic centimeters. Okay, here. The length is 8. The width is 1. Again, if you switch those, I don't care. What I care about is that you knew the height one was the 5. And then when you multiply that, I hope you didn't need a calculator. What'd you get? 40 cubic centimeters. Okay, length 16, width 8, and your height was 10. Plug all those in. How many cubic centimeters did you get? Remember, you can always pause it if you're like trying to catch up. Okay, you should have put 1,280 cubic centimeters. Perfect. Okay, I really hope you're getting all these right. This is one of the easier sections, right? Okay, hopefully you're feeling pretty smart. You have length times width times height. Well, 2 times 2 is 4, and 4 times 5 is 20. No calculator needed for that one. Okay, your length was what? 1, 2, 3. And your width was 1, 2, 3, 4, 5. And what did you get for your height? It was too tall. Okay, well, 3 times 5 is 15. And 15 times 2? Yeah, you should have gotten 30 cubic centimeters for that one. Okay, almost done. Your length was 2, your width was 2, and your height was 2. So what kind of rectangular prism is that? Yeah, cube, because all the sides are squares. They're all equal. So another way of putting this would be 2 cubed, 2 to the third power, which is 2 times 2 times 2, which is also important. Why a lot of people, like for this one, they're like, oh, I just put 30 cubed as my answer. And I'm like, no. It is 30 centimeters cubed. It is the units that are cubed. It's not 30 cubed, because 30 cubed is saying 30 times 30 times 30. No, it's not. It was 3 times 5 times 2, which equals 30. So please, please, please do not put this as your answer with the cube right next to the number, because that is very different, right? That's showing 30 times 30 times 30. It's only the centimeters cubed showing that, oh, that's your volume, because volume is always in cubic units. Okay, so this you could have put 2 to the third power, which means 2 times 2 times 2, which is what? Well, 2 times 2 is 4. 4 times 2 is 8 cubic centimeters. Last one. How'd you do? You should have done 4 times 2 times the height, which is 10. So 4 times 2 is 8. 8 times 10 is, yes, 80 cubic centimeters. Good job, my little mathematicians. Hopefully you got all those right and you're feeling very proud of yourselves. Until next time.